Hello, darling, it's me. Yeah, slight problem. I think this week's shoot is going to go on a bit longer than I thought. I think I've got on the wrong flight. Yeah. No, I won't be needing dinner tonight, no. Get ready for blast-off. This week, Click is heading to space. On the way up, we'll take in some spectacular views of Earth, swing by the moon on a spacecraft you could make at home, and then head 500 million kilometres into the unknown to hook up with a comet that could reveal the secrets of life on Earth. Welcome to Click. I'm Spencer Kelly, and welcome to ESTEC, the European Space Research and Technology Centre in the Netherlands. This is where the European Space Agency develops its spacecraft. That is a full-size replica of the Columbus module, which is currently orbiting Earth as part of the International Space Station. And this is my happy face. Some kids want to drive trains. I've always wanted to go into space. And here at ESTEC, researchers from 35 countries and with similar dreams work together to explore other worlds and progress further out into the void. The place is a real mix of replica spacecraft and working prototypes. This is the closest I will ever get to being on board the International Space Station, and I have to say, it's awesome enough for me. Of course, the major difference if you're on board the real thing is, first of all, no way is up. And secondly, if there's a problem, there's no way down. The smallest problems on Earth can be fatal in space. That's why absolutely everything that goes up is tested to breaking point first. In these vacuum chambers, the smallest components and new materials are being blasted with the extreme heat, cold and solar radiation of an orbit around Mercury. Entire spacecraft undergo the same kinds of tests in similar, if much larger, environments, because even on unmanned missions, equipment failure can mean mission failure and a ton of money lost in the vacuum. Launching a satellite into orbit is, of course, a big, expensive deal. But not all satellites are anywhere near that size. Have a look at this. This is a CubeSat. Each one is a regulation 10 by 10 by 10 centimetres, and these are packed into the gaps in a launcher. And because they're made of cheaper, off-the-shelf components, it means that smaller institutions like universities can build their own and then explore space. Now, CubeSats have been used for all sorts of projects so far, and Richard Taylor has been looking at some of the stunning results one of them has produced.
This modest office in downtown San Francisco is light years away from your traditional satellite manufacturing lab. But it's from here that a 40-strong team of engineers is working on building the biggest constellation of satellites the world has ever seen. Earlier this year, the first few camera-equipped CubeSats were ejected out of the International Space Station and into orbit.
When we saw the satellites come out of the International Space Station, it blew my mind. Because to see the things that we have actually built here in this lab in orbit with the Earth behind them was fantastic.
These CubeSats are now sending back their first images as they pass over Earth 5 miles a second.
Nowadays, we put more capability into these little satellites. They're a few kilograms than you can possibly imagine. They're much more capable than a satellite was 5 years ago that was 10 tons.
The pictures are detailed enough to pick out individual trees, which will give an unparalleled insight into activity on the planet's surface.
Instead of seeing a hole in the Amazon a few months after trees have been taken down there, we can see some loggers provide warning that that is happening.
Right now, the team is working on augmenting the few of these so-called doves currently in low Earth orbit. They aim to have 131 by the end of next year, giving an almost blanket snapshot of Earth. But this revolution in satellite imaging is not confined to simply still pictures. This is the first high-definition commercial video of planet Earth. It was taken from a satellite launched in December by another Silicon Valley startup, Skybox, already rumoured to be in acquisition talks with Google. Able to pick out moving cars, it means an even more concentrated and deeper understanding of activity on the planet.
If you show somebody a still image of an area, they can gain some understanding of what's happening, but if you show someone even just a few second clip of video about an area, we intuitively understand a lot about what's happening.
Skybox satellites are monitored closely from mission control, essential to protect its investment. Though costing under $20 million each, they're far less than the multi-billion-dollar creations which characterise older satellite technology. And this is where the satellites are physically assembled. This one here, a carbon copy of the satellite currently in orbit around Earth. Now, I'm not actually allowed inside this clean room because being inside would be a violation of international arms regulations. And it highlights the potential power that satellites can wield, offering powerful analysis, not just for humanitarian or benign corporate purposes, but for potentially more hostile actions too, radically transforming access to information for anyone with deep enough pockets to pay. Do you ever worry about information being used in negative ways?
What allows me to sleep at night is, although any radical change in information will be exploited for nefarious purposes, the number of applications that are of benefit to humanity far outweigh those sort of misuses.
Space satellite experts acknowledge this is a watershed moment, but with it comes a warning. We simply don't know where it will lead.
Richard Taylor, those CubeSats are a bit different from this thing, don't you think? This is an unmanned Russian spy satellite which spent 2 weeks in 1988 photographing the Earth from cameras mounted in the windows at the front before it re-entered the atmosphere and plummeted back down to the ground. After all, in those days, they had to get the films out of the camera and develop them before they could see the pictures. Anyway, more from space in a second after we hear what's been happening back down here on Terra Firma.
An EU court has ordered Google to amend its search results at the request of ordinary people in a key test of the so-called right to be forgotten. The European Court of Justice said links to irrelevant or outdated data should be erased on request. It comes after a Spanish man complained that a search of his name brought up an old auction notice of his repossessed home. Critics, including Wikipedia founder Jimmy Wales, warn that removing the links, even though the actual data remains, amounts to wide-sweeping censorship. Electronics giant Samsung has proposed to compensate factory workers in South Korea who have developed cancer while working for it. Following a long-running dispute, Samsung apologised for not acting earlier, but didn't admit to a direct correlation between working at its chip plant and developing leukemia. Google's headset Glass has gone on general sale in the United States for a cool $1,500. Glass has been in private beta testing for several years and then last month went on sale for just 1 day. Now Google says it will sell the headsets to anyone in the United States. It's expected that the glasses will get an update and high-profile global launch towards the end of this year.
And liftoff of the Falcon 9 rocket and Dragon.
This isn't your average rocket launch. While this SpaceX rocket may be loaded with 2.5 tons of precious cargo bound for the International Space Station, there are a few kilograms in there that could mean the start of something much bigger. The culmination of over 3 years of work, hidden away in the spare cargo space, is a device that means the personal, open-source space age has begun.
So our whole idea is mass exploration of space by private individuals. So people helping scientists do research, but also doing stuff for their own interest. And the first thing is we want to see is that actually of interest? It sounds ridiculous to say you could have your own spacecraft in space for a few £100. And, you know, is that actually possible? Can that be done?
Michael co-created KickSat, a crowd-funded project to send over 100 tiny satellites called Sprites into space, not for millions, but for less than £200 a pop. The big idea is to make satellites so tiny that you can send hundreds or even thousands up at once. Launching stuff into space can cost up to $100,000 a kilogram. But if you split the bill a few thousand ways, that suddenly becomes a lot more affordable. These Lilliputian computers are packed into CubeSats, those 10 by 10 by 10 centimetre cubes that we saw earlier, which then hitch a ride to zero-G in the leftover space on major missions by the likes of NASA and SpaceX. Once the rocket has completed its main mission, the CubeSats are jettisoned and they then deploy the sprites. But the real value of these tiny satellites is that, like similar small computers such as the Raspberry Pi, each one is customisable. Luke is a sixth form student from York. He heard about KickSat while studying astronomy at school, and since then he's been programming their software. Space software.
I had no idea that I was going to do this, and then one week I just decided to send an email, not really expecting much to happen from it. And then 4 months later I'm here waiting for the launch of a rocket which has something which I helped create on it.
If you ask these guys, KickSat means the start of the age of personal space exploration. But Michael's next project, Pocket Spacecraft, has much bigger ambitions.
We're really interested in interplanetary exploration. We want to go out and visit the solar system. So at Pocket Spacecraft, we're now working on a mission to the moon, which hopefully will be launched next year. And what Pocket Spacecraft's mission to the moon aims to do is to launch at least 2,000 of our thin film spacecraft.
Michael and his team of collaborators and volunteers around the world are working on an even thinner miniature satellite called a Scout, made from a material only 5 microns thick. That's 1/200th of a millimetre. It's all about using clever design to keep costs and weight down. The tiny wire around the edge simultaneously keeps the Scout rigid and acts as the aerial for communications. And much of the electronics on the Scout are printed using conductive ink. The only actual components are the solar cells and the central chip. With funding from the European Space Agency, Pocket Spacecraft is also working on a mission control app and website, so you'll be able to monitor the data from your spacecraft once it's up there. Pocket Spacecraft already has over 2,000 backers pledging funds to the $500,000 mission. Even though space is so vast, the best way to explore it may actually be with the tiniest of tools. What an amazing opportunity to do what these guys did, albeit remotely. But even if you can't get to the moon, even if you can't get into space, there's still plenty of exploration to be done inside the Earth's atmosphere. We sent the BBC weather presenter Peter Gibbs to Malawi to get a view of the Earth even he hasn't seen before.
Umvu National Park. The scenery is stunning, but myself and my friends Andrew and Jerry are hoping to get some far higher sights. The culmination of months of hard work is our chance to launch a weather balloon into the upper reaches of the atmosphere. When I saw somebody doing this thing of sending up cameras into the stratosphere, I just thought I had to get involved in that. And you know, it's actually a part of the atmosphere that's very hard to get any imagery of any other way, because it's too high for aircraft, but it's too low for spacecraft. So unless you've got something very specialised, these things are the only way you're actually going to get into that region of the atmosphere. And I'm not the only one. All sorts of people are taking cheap, intelligent electronics and putting it together to send fairly sophisticated packages to the edge of space and back. It's great fun, but it also has the potential to provide some very useful science. Our balloon's carrying a couple of HD action cameras, temperature sensors, plus radio and satellite trackers, so we know exactly where it is. All this is wrapped up inside a homemade polystyrene box to deal with temperatures that'll go down to -80 degrees. It's a standard 600-gram balloon, latex rubber. When you fill it with something like hydrogen, it expands as it rises and it gets so big that it actually bursts. Well, with all the last-minute preparations complete, it's almost time for liftoff, and the nerves are taking over.
3, 2, 1, go!
Success! Data on position, speed and altitude are being fed back from the balloon directly to our radio receiver, but also via satellite, as long as we have Wi-Fi or mobile signal.
I'm desperate to get an internet access so I can see whether we're getting messages, because we really are in the middle of nowhere.
This balloon also has a little something special on it. We're putting in a Geiger counter. The professor from Reading University Meteorological Department has asked us to fly this. That's the real science of this whole thing. The sun sends a stream of charged particles known as the solar wind into our atmosphere, and it's thought this may influence how clouds form. There's very little data available from the tropics, so we're helping to fill gaps in the science. Andrew, the tracker's working.
God, I'm so happy. It's look, we're at altitude 15,630 metres. Yeah. 16 kilometres. So let's go. Let's go and find it.
Not long to burst.
No.
At 22 kilometres altitude, the air is so thin it's only a matter of time before the balloon will swell and burst. While it's in the air, we can track its location, but once it hits the ground, that's not guaranteed. The chase is on to retrieve it.
Hey! 17.4 kilometres.
It's at 1 kilometre high. About half a mile that way.
There it is, in the
There it
main.
is.
That is totally amazing.
It's always a relief when you find the package, a great sense of achievement. It's taken us over a year to put this project together, but it's worked. Well, that's one project that's come to an end. We want to move to a balloon that actually goes up and just floats at a set altitude. With that, you can get onto the jet stream, you can ride the world's winds. Potentially, we could go right around the world, and that's a bit of a dream of ours.
Peter Gibbs. Now, when you think of space exploration, it's easy to focus on the spectacular rocket launches. They're only the briefest part of a mission that can span years of planning beforehand and sometimes years of waiting afterwards while whatever it is that you've launched gets itself into position. And this year, 2014, marks the end of a 10-year wait before ESA's most daring mission yet can reach its final stage. The Rosetta project lifted off in 2004, its mission to investigate the origins of life on Earth. Scientists are hoping to find out whether the water frozen into comets contains complex enough molecules to have created life here on our world. To do that, Rosetta is chasing down a comet called 67P CG. And that's the easy bit. The audacious plan is to orbit the 4-kilometre wide chunk of ice and then land a probe on its surface. All while 500 million kilometres from Earth, a distance at which any communication will take half an hour to reach it. As mission manager Fred Jansen explained, that makes it too far away to be controlled manually. Rosetta will have to fly itself. It is working autonomously, isn't it?
Essentially, yes, because everything is preloaded on board in terms of commands. We load a few days of commands and it executes it by itself, and then after 2 days we load another set of commands.
The universe's most distant firmware upgrade, I guess.
Yeah, no, it's true. I mean, this of course makes life easier in a sense that you have these 10 years, although you have to make sure that when you launch, that all the elements hardware-wise are there to allow you to do what you need to do.
One thing that will be decided by humans is the landing site. Rosetta will take images of the whole comet, and over about a month, the candidate sites will be gradually narrowed down from 5 to 2 to 1.
The reason for that stepping process is we continuously come closer to the comet, and our images, the resolution will increase. So at the time we have to pick 5, we don't have the resolution to pick the final one.
Who gets the final say on the final landing point? Is it you?
Yes.
How do you feel about that?
Well, it's my job. It's the way it is.
It's going to be an exciting time and a very nerve-wracking one too, as you've heard. Right, time to break from the Netherlands for a few minutes and head back to London, or wherever it is that she keeps that mysterious underground bunker of hers. Here comes Kate Russell with Webscape.
The rest of the team might have got to visit the European Space Agency this week, but I've been enjoying a trip aboard the International Space Station. Virtually speaking, of course. Thanks to the ISS HD Earth viewing experiment, we can all see what it's like to orbit Earth, which is rather spectacular. A picture speaks 1,000 words, so the saying goes, which is perhaps why the craze for infographics has taken off on the web. You don't need to be a designer to make your own, as there are a swathe of great tools hoping to cash in on this trend. We looked at Infogram a few months ago, and it is definitely a hot contender. The company is also about to launch a video infographic maker, which sounds pretty neat. You can sign up for launch notification on their website. If you follow me on social media, you might have heard me talk about how annoying infographics are. And don't get me wrong, done well, like the example here from Socialnomics, they are a brilliant addition to a web page and have been proven to drive more traffic. There have been lots of psychological studies too, determining that we learn and retain more from images than words. But all too often I see them used as a cheap and easy way to add eye candy to a website, bringing no clarity to the subject and in some cases just confusing it. And that is no help to anyone. Easily is another neat tool that, as the name would suggest, is really easy to pick up and start using. Just choose a theme, then drop in your data to make your graphic. If you're looking for work, Visualize.me will make an infographic out of your resume using data gleaned from your LinkedIn profile. This is one-click simple, and you'll have an eye-catching introduction to share. 'Cause all of me loves all of you. The key thing to consider when designing an infographic is what kind of visualization will make the data clearer. I think this is where lots of makers get it wrong. IBM has a neat experimental tool that lets you try out lots of different styles to see which one works. It's called Many Eyes. I give you all. Head along to the research page and try on a few styles with just a click. You give me all.
Kate Russell's Webscape. And just before we go, I thought I'd show you ESA's Mars Yard. This is where they've been testing different designs for the ExoMars rover, which is due to head to the Red Planet in 2018. For example, they've been experimenting with different types and numbers of wheels, and even the best way to control the thing from back here on Earth. Well, that is it. It's been a fascinating trip. Not just me, is it? No, I didn't think so. Hope you've enjoyed our brief voyage through the future of space travel. And if you'd like more from us, then visit our website, bbc.co.uk/click, and get in touch. Email click@bbc.co.uk or tweet us @bbcclick. Thank you very much for watching, and we'll see you next time.